Welcome to Math 105, Chapter 8.3, Measures of Central Tendency. So things like mean, median, and mode. So in our case, we're going to talk about a sample and its mean. A sample is a sequence of values of a random variable x. Now, we learned all about your random variable x's in our previous two sections. Now, the sample mean is the average of the values in the sample, whereas the population mean is consisting of all the values of x from the entire population. Now, typically when we talk about your mean, you guys are going to tell me a specific way to calculate a mean. So in our case, if we have a sample mean, we are looking at, well, you guys, I'm sure, have calculated mean before, but it's going to take each of these x values and we're going to add them all up until you run out. And then we're going to divide by the total number of values that you have, n. So if we had, let's say, test scores, if we had 5 test scores, we would add all 5 up together and then divide by 5. That's what it is to be your average. So x bar is your average. Now, when we talk about your sample mean, and we'll do population in a second, right? Your sample mean, we can actually condense into a single equation. So this again being your sample mean. We have the summation. That's what this weird looking E is called. It's the summation. It's the sum of all of your x values when I is equal to 1. So starting at your first x value is what this is saying, and then out of however many. So I'm going to define this again for you guys. This is called the sum or summation. This little I right here this is just telling us that the values start at the first given one. And then n here is just how many total you have, total number. And there you go. So that's how you can read it. We're going to be seeing a lot of this sort of idea. And I'm sure you're going to be seeing that on some of your other classes. So now a population versus a sample. So when we're talking about all of us in the room, right, that could be considered our population, right? All of us in our classroom versus those who might be sitting in the first row, right? So if you have an entire set of people, this is considered your population. Whereas we're going to take a certain number of that population. This is then called your sample. Now, this is how you say your sample mean is just x bar, or this being mu, your population mean. Okay, now sometimes they are calculated a little bit differently. In our case, we're going to be having the same, or we're going to see different variations. I should just leave it at that. Now, if this is your sample here, it is a small portion of the big picture, of the big population. So for those of us who are going to the Citadel, everybody that's going to the Citadel versus those that are taking Math 105 is another good example. Now, there's different ways to calculate your central value. So one can be the median. The median is the middle score, and the mode is the score that appears most often. So for example, can we find the mean, median, mode of these set of scores. So pause the video, see what you can come up with. We talked about your mean, right, where you can add them all up and then divide by however many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can add all 10 up. And I actually might consider putting them into an order, and you'll know why in a second. So mean, I'm going to say add all up, divide by 10. Whereas your median, we're going to put in order. So we're going to go with the lowest ones first. 85, 85, 90, 90, 90, and 100. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Now with your median, right, we're going to start to slash numbers out on either side. So 1 for 1. We're going to keep going, making sure I cancel out the right ones until we get to, now ideally we get it all to just one value. Now ours being an even number, you'll end up with 2. If you have an odd number, let's say 101, that just means one more will end up canceling. And then the leftover is that amount. Now our leftover being 85, we can just clearly state that your median is 85. However, if it's between two numbers, if between two numbers, we're going to take the middle of the two numbers. Then you can add both of them up and divide by 2. That's only if it's an even number of scores or X values to start. Now your mean, I didn't put it up here, but it's going to be 86. And your mode is what happens most often, more frequently. And notice that 80 occurs 4 times and 90 occurs 3. So we have 80 here. It is possible not to have a mode if nothing repeats, if nothing repeats, or you can have 2 modes if they are equivalent in their values. And you can see here your mean, median, and mode. Your mode is definitely a lot further off than your central values of your mean and your median. Now, which one is the best one, right? Well, the mean tends to give more weight. The mean tends to give more weight to the scores that are further away from the centers. So sometimes if you have a big outlier, you're not going to want to choose the mean because it's so far out there, it's pulling either up or down your central value. So it skews your data. Now, when the collection of items contain a wide range of scores, so it's very dispersed, the median is preferred. So when you have a really big range, the median is what you want to go to. We're just using the mean so often sometimes that we fail to remember that there are other options to us. Now, the mode can sometimes lie far from the center and is definitely used a lot less often as an indication of the center. So let's note that the population mean can be different or impossible to compute at times. So in that case, we would need to go with your sample. So imagine, right? And the reason for that is like, if you can imagine what it would take to compute the mean of household incomes for those in the US. That means we must get all of the income data, all of the data for all of the households in the US, something that's so hard to do, very impossible, right? So difficult. So we must get all the income data for all the households in the US, right? Emphasis on all, right? Something very, very difficult to do. Whereas if you have a sample mean, that can be an unestimated bias. So taking just at random, so you cannot be biased in your selection, but at random, taking a small portion of your population, we can use that as your best guess as your estimator, right? But it doesn't always fit the best parameters. So now what, right? So the mean might not always be good, right? The mean on how we normally calculate it is what it's saying, might not be the best fit. So instead, we're going to be looking at something called your expected value. So instead of looking at your sample of values, look at the probability distribution. Right, those that we've been calculating now for our semester, the probability distribution of these X values themselves. Now, what this is going to do for us is it's going to create the sample mean without having to even take the sample. It's the unbiased aspect. It's the probability of these values. Even better is that it will now make a prediction for us in the long term. So think about us holding a census, right? A household, sex, age, rate, it's over the values of 10 years, which is great for us because it is an indication over a long-term amount. So what is this expected value? How do we even work with it, right? Well, it says if X is a finite random variable, again, think about what it means to be a finite random variable. It's a set determined amount. It should end at some period, right? Over these X values, then the expected X value is going to be your mean. So E of X is another way to say your expected value. And what we're going to do is just call it your mean. So conceptually, your expected value and the population mean are different. So on a concept, on a base level, yes, they are different. However, they could be the same value. So what we're going to assume is that your E of X, your expected value, is going to act as your mean, but better yet, your population mean. Now this has its own equation, right? So pause and see if you can determine what the equation is actually telling us to do. Well, it's telling us that we're going to take your X values and we're going to multiply it by its own probability, multiply by its own probability, and then add them all up together. For a shorthand version, this just says we're going to take the sum, the summation of each X value starting at your first X value. We're going to multiply it by its own probability over an n amount of values. Now to interpret your that shorthand, right? Just down here, it says to compute the expected value. If you're looking back at your notes, you're like, what the heck does that even mean? It just means that when finding the expected value, we multiply the X value by its probability and then add up the total. So multiply by its probability, add up the total. So let's see that in action. So according to historical data, the number of injuries that a member of the University of South Carolina's women's soccer team will sustain during a typical season is given below. Compute, not computer, compute E of X, so the expected value or the mean of the injuries. So they have determined for us already that these are your list of number of injuries. So from 0 to 6, right? They don't tell us how they got it, but it's assumed that these are your X values. So X, these are the X values. Whereas below is your probability of each X value. And we said beforehand, right? The first thing we're going to do is multiply your X value by your probability. So 0 times 0.2, that happens to be 0. 1 times 0.2, right? So multiplying down, 0.2, multiply down, 0.44. See if you can pause the video and get the remainder. There you go. So for your expected value, you are multiplying down, and then let's add them all up. Add them up. 0 plus 0.2 plus 0.44 plus 0.6, and all of these values here will have a total of 2.01, which is your expected value. Now, is it possible to have 2.01 injuries? No, but again, this is an average. So it comes out to be just a little bit more than 2 injuries sustained during a season. So if we were to put that in the context of our problem, it says over a given season on the soccer team, they will sustain about, or on average, 2.01 injuries. So there is a way to do it on your calculator, which I will show you next in this one. Again, I'm not going to be using Desmos for this one. I don't know. I'm sure Desmos can do it, but I'm just not comfortable with it. So definitely go explore if Desmos is your calculator. Otherwise, I'm going to be using the calculator app called Calculate 84, or if you have a physical one, just get a TI 83 or 84 calculator. It says, what happens when it is not possible to know the probability distribution of a random variable? Perhaps, for example, a randomly selected Uber driver are selected and X is the individual's income. The following is a random sample of 1,000 Uber drivers in the US who live close to Atlanta Airport in the years 2018 and 2019. So you have the income brackets below, and then the frequency of which each has fallen in to the mix, right? So the estimate of the average incomes of all of the drivers just before 2019. Now, how did they go from this template to this template here? Well, what they're doing, right? Let's take a look at this chunk, is that because they're given a range, we're going to have to, when we go to do any sort of multiplication, we can't multiply over a range. Instead, we have to multiply a specific point. These points happen to be a rounded midpoint. In our case, and they're also called your bin values, right? Your bin being, okay, of this range, let's put it into one category, a bin. So our 25,000 is going to comprise of the middle values between 20,000 and 29,999,999. Can never say that one, right? So so for our purpose, right? Again, I'm going to do this by hand first and then show you how to do it on your calculator. Well, for those who fall in between here, we have 20 people. And if we're talking about the probability, this is the frequency. Well, what's the probability? Well, it's 20 people out of how many? 1,000. So about 0.02. If we did it again, those rounded midpoints, we got your 80 out of 1,000, 0.08. Now pause the video, see if you can get the remaining of these values. 230 out of 1,000, 0.23, 400. Oops, I made a mistake on that one. There you go. Okay, so we calculate by hand, right? We multiply, or sorry, we did all of this multiplication or division to find the probability. Now, if we wanted to, we can then do it by hand, where we then create this third box where we multiply down and then add across. However, let's make your calculator do the work. So on your TI-80, fours or threes, whatever ones that we're working with, your expected value, your E of X, is equal to the X value times its probability, right? So in this case, your X values are going to be placed into lists. X values are going to be in list 1, and P values are your probabilities in list 2. So on your calculator, we're going to select the following buttons. We're going to do Stat, Edit. We're going to do list 1 of X values. List 2 is your probabilities. And then we're going to hit second mode. And then go back to second, stat, math, sum, second, 1, second, oh, so sorry, second 1 times second 2, close parentheses. So this is what we're going to punch in. Now what that looks like. In your graphing calculator, right, stat can be found right under the DEL button, kind of in the middle. So we're going to hit stat, and then we're going to hit that first one, edit. Notice I have a lot of junk in this one. So I'm going to come up here and hit clear or second clear all, and then scroll down. So don't delete it. Don't hit that DEL. You're just going to hit second. So you're going to come up here where it's nice and pink, and then hit second clear, or you just can hit clear and then enter. So we're going to enter in all of those X values that we had from your problem. Come on. Oh. All right, there we go. 25, 35. All right, so those are all of our X values. Then over here, we're going to enter in your probability. So you could enter in your probability that we've already calculated, or you can make your calculator do the work. If we know that we have on this next one, 230 divided by 1,000, we can do that as well. And notice it'll calculate it for you. So I'll do that one more time. 400 divided by 1,000. Again, it'll pull that up. Otherwise, we already did the work for some of these, so I'm just going to enter them in real quick. All right, So you have these values here. Make sure that you double, if not triple check them so that we're all on the same page. I'm just doing the same thing. Okay, now we're gonna hit second mode. Mode is right up by that second button. It's the one right next to it on the right. Then we're gonna hit second stat. You're gonna go over to math and then all the way down to sum. Notice that you can also do your mean and your median here. We want something specific. We want your expected value. So we're gonna hit sum. And then we're going to hit second one. The second button is going to pull up any value that's in blue on your calculator. We're going to multiply it, so times second two, close your parentheses, and hit enter. So your expected value, your median outcome is going to be $54,500. I'll put that right here. $54,500. And there you have it. All right, so that takes care of any sort of finite random variable, but let's take a look at what we would do if we have a binomial random variable. So if we only have two outcomes, a success or a failure. So suppose you're taking an all multiple choice question, multiple choice test, 25 questions each with 4 possible answers. You can choose to guess on the whole thing. So what score are you expected to get if you guess on the whole thing? So when we talk about your Bernoulli trial, right, those two outcomes, right, well, how many, we always want to start with the number of trials, right, your total number. In our case, total number of questions. Well, we have 25 questions in total. And what is your probability, right? The probability of success. Well, if we're a multiple choice with 4 correct responses, 4 possible outcomes, right? There's only one way to succeed. The remaining are failures, right? So let's say C is your success, right? The right answer. And D is, or anything else is the wrong answer. So what is the probability of success? Well, it's 1 out of 4, right? C is 1 out of 4 possible choices. So this is for the correct response. So if we're taking a look at your expected value, keep in mind we said your expected value is when you have X, right? Your X value, the number times the probability, right? Our value of N now times the probability of your success. I'll just put probability P, which means we have 25 questions out of, times 1/4, the correct response, which means we have a total of 12.5%. That is what our score would be, a 12.5. Now, can we actually get a 0.5? It's up for debate. But again, this is the average score we would get on a 25 question test, all with multiple choice of 4 answers. So to find your to make more of an equation, we're just going to say for any sort of binomial that we have 2 outcomes, either it's right or it's wrong, your mean or your expected value is equal to the number of trials times P. Number of trials times P, which is the probability of success.